This video is titled Horizontal Motion in One Dimension with Calculus. Remember, college physics is algebra-based physics and university physics is calculus-based physics. So ask your physics teacher if you're learning algebra-based physics or calculus-based physics, because maybe this worksheet is not, or this video is not suitable for you. Question 1. The position of Kenny's Porsche as he zooms down the x-axis is given by the function displacement as a function of time equals 5t cubed plus 4t squared plus 3t plus 6. Part A. Find formulas for his velocity and for his acceleration as functions of time. Velocity as a function of time is the derivative of displacement with respect to t. Acceleration as a function of time is a derivative of velocity with respect to t, or the second derivative of displacement squared with respect to t. Part B, find his initial position, velocity, and acceleration. So we have equations for his initial position, his initial velocity, and for his initial acceleration. So initial position means time t equals 0. So we have his initial position is 6, initial velocity is 3, initial acceleration is 8. Part C, find his average velocity for the first 3 seconds. So average velocity is total displacement over total time. So we use this equation. So I apologize, it's not total displacement, it's change in displacement. It's x final minus x initial. So the numerator here is x final minus x initial. Question 2. The acceleration of Oliver's BMW as he zooms down the x-axis is given by the equation a equals 42t. At time t equals 2, his velocity is 144 and his position is 200. Part A. Find formulas for his velocity and for his position as functions of time. So to determine his velocity, we need to take the acceleration, the integral of the acceleration, because we were given acceleration. So question 1, we were taking the derivative of displacement to find velocity and acceleration. Question 2, we're going to take the integral of acceleration to find velocity and the integral of velocity to find displacement. So you could see what I did in part A. The integral of acceleration is going to be 42t squared over 2 plus a constant. And we have an initial condition, which is at time t equals 2, velocity is 144. This is from the problem, just read it. We plug in the numbers for the variables to solve for the constant, which is 60. So our equation for our formula for velocity is this, 21t squared plus 60. Now let's find an equation for the position or displacement. We're going to integrate velocity. Here's a function for velocity. We integrate, we get this. So we have an initial condition for displacement. At time t equals 2, displacement is 200. Plug in the values for the variables, we get c equals 24. So x is equal to 7t cubed plus 60t plus 24. Part B. With time on the horizontal axis, sketch graphs of displacement, velocity, and acceleration. So this is a graph of displacement versus time. This is a graph of velocity versus time. And finally, this is a graph of acceleration versus time. So I drew these graphs from the website desmos.com, DESMOS.com. Question 3. The bell rings and Mr. Harvey dashes out the door of room 25. However, he is attached to his desk by a bungee cord. His position along the x-axis is given by the function x of t equals 60t squared minus 5t cubed. Part A, find formulas for his velocity and for his acceleration as functions of time. So if we're given displacement, we could take the derivative of that to find velocity, and we could take the derivative of velocity to find acceleration. That's exactly what I did. Part B, at what time is his position 0? Well, we're given the equation for displacement or position. Set that equal to 0. That means the position is 0. Solve for time. And at times t equals 0 and 12, his position is 0. At what time is his velocity 0? So we have this equation for velocity. We have this equation for velocity. Set it equal to 0. And then we could solve for time. So at time equals 0 and 8, his velocity is 0. At what time is his acceleration 0? Take the equation for acceleration, which is 120 minus 30t, and set it equal to 0. This is a mistake. This should say a. Okay, should say acceleration as a function of t. At time t equals 4, his acceleration is 0. Part E, during what time interval is his acceleration positive? Is his velocity positive? Is his acceleration positive? His position is positive from 0 to 12. How do I know this? Well, take this equation for position and just graph it using a GDC, a graphic display calculator. Part F, sketch a graph of his motion on the XY axis. So from time t equals 0 to t equals 8, he goes from position 0 to 1280. And after time t equals 8, he's going to go from 1280 back down to 0 and to the negative position, displacement. So at time t equals 0 and time t equals 12, he's at position 0. And at time t equals 8, his velocity is 0. Part G, sketch displacement time, velocity time, and acceleration time curves. So I graphed these using the website desmos.com. This first graph is position versus time. The second one is velocity versus time. The third one is acceleration versus time. Part H, find his location at time t equals 1 and t equals 10. So we just have to look at the displacement equation or position equation and plug in t equals 1 and t equals 10. Part I, find his average velocity from t equals 1 to t equals 10. So let's find the displacement and divide by 9 seconds because it goes from 10 seconds to 1 second. Part J, find his average speed from t equals 1 to t equals 10. So first let's determine the distance Mr. Harvey travels from 1 second to 8 seconds because he's going to the right. Then let's determine the distance Mr. Harvey travels from 8 seconds to 10 seconds because that's when he moves to the left. So Part I is about velocity. We care about displacement. Part J is about speed. We care about distance. So that's the difference between part I and J. Total distance traveled, we have to use 1225 plus 280. Part K, find his average velocity and average speed from t equals 1 to t equals 13. So you could see what I did here to find his average velocity. It's the change in displacement. So it's going to be minus 845 minus 55 in the numerator. And it's going to be 13 minus 1 in the denominator. Now let's find the average speed. Determine the distance Mr. Harvey travels from t equals 1 to t equals 8 is step 1. Then determine the distance Mr. Harvey travels from t equals 8 to t equals 13. So that's the total distance traveled, 1225 plus 2125. That's here. And the total time is 12 seconds. So you could see average velocity and average speed give you different answers, because velocity is about displacement, speed is about distance. A space shuttle accelerates non-uniformly with acceleration equals 25 times 1 minus e to the minus t. Find his acceleration at time t equals 0 and at time t equals infinity. So you could see what I did in part A. I just set t equals 0 and t equals infinity. Part B, the shuttle's initial velocity is 0. Find a formula for its velocity as a function of time. You could see I integrated acceleration. I have a plus constant, so what I need to do is I need to use that initial condition, v of t equals 0 to solve for the constant. Part C, the shuttle's initial position is 0. Find a formula for its position as a function of time. So I integrated the velocity. I have a plus constant. I use the initial condition to solve for the constant. Sketch AT and VT curves. This is a AT curve. And this is a VT curve. So I use the website desmos.com again. Question 5. A particle attached to a spring is confined to move back and forth on the horizontal axis between x equals minus 60 and x equals plus 60. There's no friction. The origin is the equilibrium position. The position of the particle is given by the function x of t equals a cosine omega t, where omega is given in radians per second. For each of the following, determine if x, v, and a are positive, negative, or 0. So imagine if we're to the right of the origin, 0, and we're moving to the left. Well, velocity is negative because we're moving to the left. Acceleration is negative because we're speeding up to the left. And displacement is positive because we're to the right. Look at this second image here. We're at the equilibrium and we continue to move to the left. Well, velocity is negative because we're moving to the left. Acceleration is 0 because write this down. At the equilibrium position, acceleration is 0. And x is equal to 0 because we're at the equilibrium position. So x equals 0. Look at this third image here. We're at minus 60 comma 0. So the object stops. So the velocity is 0. Acceleration is greater than 0 because the spring is pushing the object to the right. And x is less than 0 because we're to the left of the equilibrium position. The next image, the object is moving to the right, but we're to the left of equilibrium. So the velocity is positive, the acceleration is positive, because we're moving to the right and speeding up. And x is less than 0 because we're to the left of the origin. Look at the next image. We're moving to the right, and we're at the equilibrium position. X is 0 because we're at the equilibrium position. V is greater than 0 because we're moving to the right. And A is equal to 0 because at the equilibrium position, acceleration is 0. Look at this next image here. We're to the right of the equilibrium position. The velocity is to the right. So velocity is positive. Acceleration is less than 0 because we're slowing down. And the position is positive because we're to the right of the equilibrium position. And finally, the last image shows that we're at rest at 60 comma 0. X is greater than 0 because we're to the right. Velocity is 0 because the object stops. And acceleration is less than 0 because it's being pulled to the left. So this object is being moved left and right, left and right, left and right, just vibrating left and right. Part B, find a formula for the particle's velocity and acceleration. Take the derivative of the displacement to find velocity. Take the derivative of velocity to find acceleration. Part C, at time equals 0, 3, 6, 9, and 12, calculate the particle's position, velocity, and acceleration. Please set your calculator to radians. So I just set my calculator to radians, and I use the equations to solve. Part D, calculate the particle's average velocity for the following time intervals. So you could see what I did. I went to the website integrals.com, integrals.com, to solve for these, to calculate these integrals. And these are the values that I got. Part E, calculate the particle's average speed for the same time intervals. So you could see what I did here. Part F, at x equals 30, calculate t, v, and a. So first I solved for t, and then after solving for t, I could substitute that into the v and a equations. So what exactly is happening in this problem? It takes, let's see how long it takes. It takes 12 seconds for the object to go from plus 60 to minus 60, and from minus 60 to plus 60. So it takes 12 seconds for one oscillation, which is 240 centimeters. Let's say the units are centimeters. That means it takes 6 seconds to go from 60 to minus 60. So it takes 6 seconds to go 120 centimeters. So it takes 3 seconds to go from 60 to 0. And that's why I got these values. It takes 12 seconds to go from all the way to the left and all the way to the right. So that's 60 plus 60 plus 60 plus 60. It takes 3 seconds just to travel 60. it takes 6 seconds to go from plus 60 to minus 60, which is 120 centimeters.